Hey, this is Travis Kassab. In the previous videos, we talked about the evolution of blockchains from Bitcoin, the first ever blockchain created in 2009, to Ethereum, the first ever smart contract blockchain, where now you start to have a Web3 ecosystem develop on top of it with decentralized applications. This is what a smart contract blockchain allows for. Now we move to the third era of blockchains, which is this proliferation of many emerging layer ones coming out at this time, with different design teams, different founding teams, all with unique design philosophies and approaches to solving the next era of blockchain 3.0. So let's get into it. We ended off in the last video talking about Ethereum and how it is transitioning to Ethereum 2.0, which is going to be a major software upgrade for Ethereum. It is going to hopefully scale the blockchain to hundreds of millions of more users. It could onboard many more people into the Web3 ecosystem. But Ethereum is not the only layer one smart contract blockchain in this space by any means. There are many emerging blockchains coming out now, and these, with different founding teams, they all have these different ideas on what blockchain 3.0 should be. They approach it with different proposed software architectures. Some are still in the making. Some have already been released and already have user communities. Which brings me to my next point, which is that these layer ones are a lot like nation states. They have their own developer communities. They have their own end user communities. They have a development culture. They have an ethos around what a blockchain should be. And the blockchains also have their own currency, right? So they have their own culture, they have their own currency, and they have their own economy, which are the decentralized applications that are building on top of these layer ones. These other layer ones are sometimes called ETH killers. This space can be divisive, right? So they're naming themselves, or people in the community call them Ethereum killers. A big reason why people think Ethereum might die is if it can't scale. If the network fees never go low enough to where, or decrease enough to where the average person can use it and send microtransactions on it. So this is one reason why these ecosystems can be sort of divisive. The culture in general can be immature because people are invested in the ecosystems that they're invested in. They're financially invested in, right? They've purchased these cryptocurrencies and they want their layer one blockchain to win out at the end of the day. This is something toxic that I think it's called chain maximalism, that you think that there's only going to be one perfect layer one blockchain and that is going to be a winner take all type of scenario. We've seen a lot of monopoly type behavior and winner take all behavior in previous tech revolutions like the internet. Like how many people do you know use an alternative to Google? Google is this monopoly on the search engine. So these big platforms like Facebook and Instagram have something called network effect, right? Where I could completely copy the code of Facebook and deploy Travis book and try to start getting users to sign up for that and create an account. But it would be very difficult because the most attractive thing about Facebook is that it already has a community of billions of users. So let's say you've been living under a rock and you don't have a Facebook account in the year 2022. When you're looking at the different social medias to create an account on, you're going to do it where your friends and family currently are. And this is called Metcalfe's Law. Metcalfe's Law is that the value of a network is proportional to the square of the amount of nodes in that network. And this is a theory that macro investor Raoul Pal has talked about many times. He basically says that the same goes for a crypto network or a layer 1 blockchain. The value of that blockchain is correlated or proportional to the amount of users that have adopted that blockchain. One metric you can look at are the active wallet addresses of a blockchain network, right? Every time a wallet is created and people send transactions to the blockchain, it gets registered, and you can see basically how many people, it's a proxy for how many users are on that network. And Raoul Pal has showed that this active wallet address is correlated with the price of the crypto network. So that is very interesting, and it tells us that these layer 1 blockchains are competing with one another to attract developers to build dApps on their system, and then also to attract, these dApps will attract end users. And these end users are going to purchase the native cryptocurrency, and that is going to drive the price of that crypto network up, okay? So this is why it can feel like a winner-take-all scenario, but actually what we will probably see, and there's growing evidence for, is that multiple blockchains are going to win out at the end of the day. We already talked about how Bitcoin and Ethereum solve two different use cases. They're optimized for different things. Bitcoin is simple and it solves the problem of a decentralized digital currency very well, and it is seen as a store of value. This is one design approach to blockchains. Ethereum is more like a platform. It has a layer of complexity added on top of it, and it can run smart contracts. So it allows for people to deploy decentralized apps on top of it and build out these beautiful Web3 ecosystems. So why would we think that things are going to change now in the blockchain 3.0 era? We can imagine blockchains whose designs are specialized for specific use cases. So let's say that one blockchain is going to be used for a decentralized social media service. This service has to account for millions of transactions coming in per second. Anytime somebody likes a post or posts a picture, millions of things are coming in per second, kind of like, you can think of Twitter and Facebook today. But there's not much value really being transacted on that network. So basically we're saying we need a blockchain that has very quick processing speeds, but doesn't necessarily have to have the highest security guarantees. Whereas on the other hand, we can think of a blockchain network worth trillions of dollars where traditional financial institutions are now transacting value on them. And so these institutions need to trust this blockchain, and this blockchain is worth much more. Maybe it's running decentralized financial applications on top of it than the decentralized social media blockchain. So this blockchain, maybe it can, it's okay to have fewer transactions per second, but that it can process, but it needs to have much higher security guarantees. If this network got hacked for some reason, then trillions of dollars could be lost. So this is it's one argument for why we will probably have multiple blockchains win out over the next 5 years, 10 years, and further out decades. Now let's talk about what blockchain 3.0 is actually about. What are these new blockchains going to improve on from blockchain 2.0? They all appear to be doing several things in common, even though they have a variety of different designs and software architectures, ethos, and philosophies. They are all doing three things in common. The first is that they are transitioning from proof of work, which was the original consensus mechanism on Bitcoin, to proof of stake, which I'm going to talk about in a second. The second thing that they're doing is they're all trying to solve blockchain scalability. They saw the problems that Ethereum is running into with high network fees, and they're all trying to solve the scalability issue to process more transactions per second and make it cheaper to send transactions. So Solana is a good example of this. They've been laser focused from day one on having very fast and cheap transactions, and all the transactions cost like 0.00000 like $25, right? So like sub penny transactions. This is a good example of a blockchain that is currently solving this scalability problem. Although, and I don't want to get into detail here, but they are sacrificing in other areas such as decentralization. Ethereum is considered more decentralized than Solana, for example. But this is a trade-off that we're going to see, and it's just something to keep in mind when you're comparing different layer ones. Now let's talk about proof of stake. We talked about proof of work before. This is a very deep and technical concept that I don't fully understand, but it's where basically a node is going to spend electricity to create a block, to get the privilege to create a block and earn a block reward on a proof of work network. This, as I already mentioned, has been criticized because it's not environmentally friendly. Right now, the Bitcoin blockchain is producing the amount of CO2 emissions that the entire country of the Czech Republic consumes in a year. So this is not insignificant, and it's been criticized by environmentalists. Now, the next innovation in consensus mechanisms is proof of stake. And all of these blockchain 3.0, this version 3.0, are transitioning to proof of stake. What is proof of stake? Proof of stake is, in order to participate as a validator node in a proof of stake blockchain, you need to stake your cryptocurrency. You need to stake that blockchain's native token. And this is essentially a security deposit, right? So you put in this security deposit, and then it allows you to potentially create blocks or vote on the blocks that you want to be added to the blockchain. If you are a node that is in some way undermining the blockchain, let's say you're creating blocks that are going to benefit you and you're falsifying information somehow, you're somehow undermining the blockchain, then your stake can get slashed. So you have a direct financial incentive to act appropriately and to, in a healthy way, maintain this proof of stake blockchain. And the amount of stake that you put in is proportional to the chance that you have of being a validator, of being chosen as a validator node. So the more money that you have put in, the more stake that you have in this network succeeding, the more likely you're going to want to have this blockchain stick around and not attack it. Because if you attack it, then you're going to lose your money, your crypto. This is a very new concept, but a lot of these blockchains are starting to implement it. And proof of stake is 99.8% more energy efficient than proof of work. So this is one reason why they're making this transition. So that is just some background into what proof of stake is. It's a very technical concept. Let's not get into it as product designers. We'll leave that for the blockchain developers and engineers, and all respect to them for doing that. The reason that I pause and talk about staking is because it unlocks this brand new passive income vehicle for end users. So I told you before how validator nodes post their crypto, they stake it, and now they can produce blocks, they can vote on blocks, and they earn block rewards for doing this and for risking their crypto in the first place. This is the incentive that these nodes have to maintain the blockchain and to work as a validator on the blockchain. Now, end users, they don't even have to become a validator node. What they can do is they can delegate their crypto to a validator node. They can essentially say, you can use my crypto as part of your bigger stake that you are using to participate as a node. And so the users who delegate their crypto, now they're going to get a cut proportional to the amount that they delegated to the validator of the block reward. So I know that was like a really bad way of explaining it, but they are essentially getting this passive income from delegating their crypto to the validator nodes. It's a lot like a bond where you buy a bond and you get passive dividends. You get a yield from the bond paid out to you every month. This is a brand new passive income investment vehicle that many people think it's going to grow. We can see right here all of the proof of stake blockchain networks: Solana, Ethereum, Terra, Cardano, Avalanche, Polkadot, and we can see that they have all of these. This reward is the yield that you get for delegating your crypto, right? So they have different yields, and this is another way how you can compare these layer ones to one another. Look, Polkadot has 14% yield. This is unheard of in the traditional financial world where interest rates are around 2% on 10-year bonds, for example, around that right now. So, I think this could revolutionize the financial sector as well, and this is all being powered by blockchain 3.0. So now we've discussed all three areas of blockchain: Bitcoin, Ethereum, smart contract blockchains, and now blockchain 3.0, with this emerging landscape of new layer ones that are throwing all sorts of different designs at the blockchain problem. Really excited to see what comes out of this and what new Web3 technologies get built on top of these layer ones. The funny thing about all this is that the end user really is not going to care about what layer one is powering their decentralized application. All that they see is that they go to Uniswap, which is a decentralized app for swapping tokens, and they just want this thing to work. They just want their tokens to swap and for everything to be seamless, but they don't care if it's Ethereum 2.0, they don't care if it's Ethereum or Solana, Polkadot, any other blockchain. They just are expecting this to happen. It would be like if the end users currently cared about the database technology that Web 2 applications are using. Like, do we really care if Facebook uses MongoDB or MySQL and all that? But I tell this all to product designers to give a background on blockchains, because I think it's important for us to understand where blockchains came from, but then to understand the landscape of layer one blockchains. Excuse me. Each one of these blockchains have Web3 economies and ecosystems built on top of them. And this is likely where you're going to sit at that layer 2 level as a product designer. And so it's helpful to understand the layer ones that are powering that economy, and then to compare those different ecosystems. So you maybe you have an informed way, or you can make an informed decision on which layer one is best for your product's use case, or which layer one you think will persist decades from now. So in the next video, we're going to quickly talk about a framework for how to compare these layer ones to one another. Like, what are the different pillars that you can compare these things against? I'll give you just a sneak peek that you can compare it on the design of the blockchain, like what consensus mechanism it's using and what performance it has, like transactions per second. You can compare the on-chain data to look at the health of the ecosystem. You can look at its tokenomics or monetary policy, like Bitcoin has one, Ether has another, and then DOT, Kusama, SOL, Sol for Solana. All of those have different monetary policies and will affect how that blockchain is valued. And then finally, like, what is the community surrounding these layer one blockchains? What's the philosophy? What's the ethos of the developers? Who are the influential figures? And then how are these blockchains fundraising their money to continue the development of the blockchain? So we'll talk about all of that in the next video. Thank you guys.